In this video, we're going to discuss energy changes in chemical reactions and some introductory thermodynamics. First, let's talk about some definitions. Chemical energy is the potential energy stored within the structural units of chemical substances. What this means is that chemical energy is due to the spatial relationship between atoms. So let's look at the reaction I have here where two hydrogen gas molecules react with one oxygen gas molecule and are transformed into two water molecules. On the reactant side, the hydrogen atoms are bound to each other. On the product side, the hydrogen atom is now bound to an oxygen molecule. We've changed the structural units and the spatial relationship between those atoms, and there's an associated energy change with that process. Thermal energy, on the other hand, is the energy associated with the random motion of atoms and molecules. Notice that we can monitor changes in thermal energy by measuring temperature changes. So as the temperature increases, the thermal energy also increases. Let's remind ourselves, how do atoms and molecules move? How is this thermal energy partitioned within the different modes of motion available to molecules? Molecules can move in three different ways. Translational, that's where they move in X, Y, and Z, so they translate or move in three-dimensional space. They can also rotate, so that would be kind of spinning in three-dimensional space. Molecules also have bonds within them. Those bonds are capable of vibrating, so that's a vibrational motion. So how is the thermal energy partitioned within a molecule? That energy is spread out into translational, rotational, or vibrational modes within the molecule. There are 3 laws of thermodynamics and a 0th law, so 4 total laws. Let's talk about the 0th and the first law of thermodynamics here, and how that relates to work and heat. The 0th law of thermodynamics states that objects within the system will exchange energy until they reach the same temperature. This is the 0th law because it's actually kind of silly if you think about that. Clearly, two objects that have different temperatures will exchange energy until they have the same temperature. The first law of thermodynamics states that energy is conserved. That means that the total energy of the universe is constant. The way we write this in chemistry is that the internal energy, which we give the symbol U, the internal energy change of the system must be equal in magnitude, opposite in sign, to the internal energy of change of the surroundings. All that's saying is that if energy leaves the system, it must enter the surroundings. Conversely, if energy leaves the surroundings, it must enter the system. Let's talk more about internal energy. Internal energy is the total energy contained within the system. The change in the internal energy is due to the sum of the heat plus the work. Internal energy, heat, and work all have units of joules. What is the difference between heat and work? In order to answer this type of question, we need a molecular perspective. First, let's look at work. Work is the energy that results in the concerted motion of molecules. What that means is that energy enters the system and all the molecules move in the same direction. In contrast, heat is energy that enters the system and results in random motion, stochastic motion of molecules. Both heat and work are ways that energy is added to or removed from the system. Work is in the form of concerted molecular motion, whereas heat is in the form of random molecular motion.